1.5 million square feet of concrete pavement as well as part of the project. With that, I'm going to turn it over to Tom.
Thanks, Mike. We can touch a little bit on the project schedule. So this project began around about end of June 2020. There was no design or any survey started before that. So end of June, we had to start project topo, site annexation, platting, permitting and design. It was a couple weeks later, we had our first meeting with the city of Fargo in early July. Started kicking submittals to them shortly thereafter. It was about early September when construction first began, and construction was complete the following September 2021. So about 15 months from the start of design to completed construction. It's pretty impressive. So how are we able to do that? A few things. Obviously, Ryan companies had to devote a pretty large construction force, which they did. We had to manage the project exceptionally well. We also had to change our design approach. So the slide you see here is kind of how we broke up our design and our submittals to facilitate that. And really it was about getting that critical infrastructure in for the critical path construction. So two-stage, first was the building pad, getting that building pad up to grade so we could install our stone columns and our footings and work on the building throughout the winter. And the second stage was finish the site utilities to be able to begin paving in early spring. So this is kind of how we did it. You can see the first set of plans was concept. This was internal, not shared with the city, but was done to get contractors bidding and enter into contracts with the owner. From there, we got approval for site access and stockpiling. So the contractors could move to site, build their access roads, and begin stockpiling that sand for the building pad construction. From there, we move into the mass grading and utilities. That's where the bulk of the site work was done. And then we completed with the final site plans for all of our city permits and approvals. In addition to the site, we also constructed 44th Avenue, which is an industrial street, city street. Similar design approach, broke it up into underground and paving plans. This was done to help expedite that city review process and begin construction sooner. In addition to this, Ryan companies and Amazon actually took on the cost of the project so that they can manage the schedule and sort of shorten up that longer duration city bidding process. A short little video here, which I'll play. Here we can see Amazon looking in from County Road 81. Panning here along 44th Avenue at the bottom of your screen. Parking lot there is over 1,000 parking stalls to meet their peak demand during the winter months. Tried talking them really hard out of the speed bumps. They wouldn't budge, so a lot of speed bumps for the snowplows to hit. But all right, so in addition to the or to meet this accelerated schedule, we obviously needed really good city coordination. This started early on with design meetings with the city. Pretty much had weekly coordination as well as continued coordination throughout construction. Kind of talk a little bit more about city and planning. I'll hand it off to Sara.
Thanks, Tom. You and Michael did a good job of introducing the project here a little bit, and I'm going to go a little bit deeper and talk about the traffic and planning portion of this project. Here's just another overview of the site. So you can see in the lower right-hand corner is Hector International Airport, I-29 running north and south there, and the four circles on the slide here are the key intersections that we focused on for our analysis. I'll step back one second. So one of the main things that we needed to determine here in our project is what is missing from the existing roads right now. And turn lanes was one that was something we evaluated through level of service analysis. So we had traffic and some trips added because of the site, which I'll get dig into a little bit more here on the next slide. So we really were focusing on the near-term improvements and not so much the long-term improvements. But you can also see the last two bullets there were some things that maybe would need to happen with the bridge, looking a little further out. So next, like I mentioned, trip generation is a really big piece of any traffic study. Particularly to a big facility like this where, you know, nothing was there previously, but we're putting a big, huge building out here. So the data was originally provided by Amazon, and it was similar to some of their other facilities. We did do a back check and verified that the data they provided coincided with the Institute of Transportation Engineers trip generation manual, and things synced up pretty well. So we did more an average AM PM peak, which is all the turning movements that you can see up there, the arrows and the numbers. So we besides just the daily peak, we did an additional peak season sensitivity. So the busiest months, you know, around that Christmas holiday time, we also looked at that at a high level too, to see if the improvements would work for that as well. As you can see on this slide, there's a bunch of red arrows, and I want to mainly focus on the 3 eastern intersections. Again, we didn't do any changes at the I-29 ramps, but said in the future, these may be needed. So the main intersection there with the 5 arrows is County Road 20 running east and west, and then County Road 81. So that one has the most improvements. The middle picture you can see there is looking north, I believe. So there was a northbound to westbound right turn lane, so the trucks could get out easier. And then also in that picture, you can see a temporary signal that's installed right now. Also looking at the top picture there, that northbound right turn lane into the facility, that was important as well to get the trucks and the employees out of the main through lane there on 81. Next, like Thomas said, collaboration was key, not just in construction and surveying and all those components related to the design, but also in our traffic study and the planning. And so there were multiple meetings, whether they were via Zoom, good email correspondence, phone calls with Ryan Companies, who was very, very responsive, City of Fargo, DOT, Cass County. So that collaboration was key here. Another piece that maybe is a little different to our standard traffic study was presenting data throughout the analysis, not just at the end to get the client's feedback, but had that process throughout. Like I said, timely responses and communications were definitely key for this project. And with that, I will turn it over to Ezra, the dirt man.
It's nice to have such a wonderful welcome. As everybody knows, our best work is buried underground. To steal that from a large earthwork contractor and specialty contractor. It's a Braun Intertec, us hired to do the geotechnical engineering, and we also stayed on and did the materials testing throughout this project. So at the beginning, like most geotechnical folks, we want to drill a whole bunch of holes. So we drilled, this is a 1 million square foot building. The majority of our borings were within the building footprint, but as you can see on that early site plan, there's an awful lot of ponds around to be able to ultimately control a lot of the stormwater runoff. Ponds, parking areas, as well as the building itself. Another thing in the image, you can see there's, you know, trees behind that, possible low-lying grounds. You know, was there a potential for, you know, some wetland, and not wetland in that way, but just soft subgrade areas that we looked at. So the geology that we hit here, if anybody's been in Fargo too much, you know, or the Red River Valley, we're blessed and cursed with very consistent geology through the region. So we're made up of, or underneath the whole Red River Valley, there's a roughly, call it 20-foot crust of slightly harder material. And then below that, you've got 70 feet of goose poop, as I affectionately call it. Once you get through that crust, anytime you apply a really big load in area or in magnitude, those soils, that Brenna and Argusville material experiences settlement it experiences settlement slowly, but also quite a bit of it. So on this project, as I mentioned, there's obviously some wetlands in that original picture, potential, it's part of the floodplain. So we needed to raise the building up. So as we're raising this building up out of the ground, 6.5, 7 feet of grade raise, that's 800 pounds per square foot of soil roughly that goes onto the ground over 1 million square foot plus area. That ultimately got to the point of just based on that grade raise alone, you know, we're predicting roughly 4 to 6 inches of total settlement. And then in addition, another 3 inches of settlement predicted for the foundation loads themselves. Amazon obviously is a large warehouse facility, spread the columns out. That brings all of your loads higher as they spread those columns out. But Amazon themselves, they're used to dealing with tolerances of 1 inch or less as far as allowable settlements for their facilities. So it was a approach that took a lot of collaboration, working with both Ryan companies, working with the third-party reviewers for geotechnical and structural, Amazon themselves, to really take a look at, you know, how feasible is this building. And so the first approach, in order to kind of make the settlement not be a problem, would have to support the building on driven piles. That would be part of a bigger process in order to do that, but ultimately it wasn't the cost that drove Amazon away from driven piles. It wound up being construction time more than maybe a lot of people. Amazon time is money. So if they couldn't have this building in service before Christmas season of 2021, being August of 2021, it cost them an awful lot of money to miss those deadlines. So we spent a lot of time talking about timing of settlement. You know, that upper crust material, that settles relatively quick. That next 70 feet of soft material, it takes quite a while to occur. The settlement within that zone is going to happen over 30 years. So it's not something the building's going to feel right away. And then the other thing is, we're not just building up 6.5 feet right at the perimeter of the building. We're building up all the way around. You know, so that whole site, 1 million square feet, 2 million square feet, by the time you add on, you know, the parking lots as well, all of that settlement is relatively happening uniformly. So really the concern winds up being differential settlement, more so than total settlement, because it's happening slowly and consistently across the site. So ultimately we came to the point of, let's control the foundation settlement to 1 inch or less. And so the best way to do that for us on this case was to work with a design build contractor. We sent it out to several folks who do stone columns, as well as other improvement options. Ultimately, a stone column vendor was selected. They provided a solution that was designed and built, installed to control settlement to less than 1 inch for the columns. We also worked to build in a 30-day waiting period for each section of the building. After they raise the building to grade, wait 30 days before pouring foundations as a part of it. And then an awful lot of monitoring as well, that we ended up doing the settlement plates. So we had roughly 15 settlement plates on this site for the building pad itself, monitoring settlement as it occurs. Ultimately, each plate was showing in the neighborhood of 4 to 6 inches of settlement. So at least our recommendations were reasonably close to what was occurred during the course of time that we were monitoring on site. So the biggest construction effort, once the design was done, you know, a lot of assistance, we were trying to provide the team with how do we help to make this construction happen quickly and efficiently without a lot of lost time. And we had several different ways that we ended up doing that. For the building itself, the approach was to break it into thirds, do some site stripping, place your settlement plates, place your grade raise fill, monitor for 30 days, and then build your foundation, followed by your precast. They did that in thirds, but when we started the building, remember we started this, Tom said we got the go ahead late June. So by the time geotech's done, construction site, the land's acquired, it's after Labor Day that we're starting grading on a large site in Fargo. Soils are soft, they're wet, they're over optimum, they take a lot to dry back. We didn't have time. That usual way is to do it with farming the materials to dry it back. In this case, time is money once again. So they brought in lime used lime treatment material, lay the lime down like this, and then run over it with a reclaimer. Ultimately blend that lime into that upper 6 to 12 inches of clay, and it dries it back through the chemical reaction between the lime and the water and the clay. You get a compactable subgrade that you can build on. And then we're bringing sand over. So the construction team ultimately secured a separate site to stockpile That whole time we were doing design, there was an awful lot of stockpiling going on to get the material close to the site, so that when they got the go, that 6.5 feet of sand could be placed as quickly as possible. Placing and compacting the sand as we go, and then we get to the point of doing foundations after that 30-day wait period, installing stone columns followed by foundations. So we've talked a lot about the building. Obviously, as in any typical site, there's a lot of other things going on. The whole time this building construction's going on, they got utilities around the perimeter coming in from the streets. They're digging ponds. They're mixing lime treatment within the material before they excavate it from the ponds in order to, again, bring the moisture contents down. At the end of the construction season, we ultimately added cement treatment to a lot of the haul roads in order to help reduce the downtime in the spring from frost boils and get it to the point where they're ready to place pavement as soon as possible. And then added kind of towards the later parts of the project, design portion was 44th Avenue South. So that was also built at the same time. Just an aerial photograph here as I finish up. The on the right-hand side of that photo is the wet eastern third of the building. They've got foundations going into place right there. The middle portion, they're putting in stone columns. And then the right portion is kind of a staging area waiting period right now in the middle of those 30-day waiting periods. And then you got ponds, parking lots around the perimeter as well. So a lot going on. A lot of coordination and effort went in with everybody involved. With that, I'll turn it over to Chris.
Thanks, Ezra. So I'm gonna go over some of the survey responsibilities on site. Initially, we did a boundary survey to annex the county property into the city. We established control networks, completed a topographic survey, and then did construction layout. Some of the layout that we were responsible for was the 30,000 linear feet of utilities, all the building grid lines so they can install stone columns and all the vertical steel columns. All the site elevations. And then we kept track of, we monitored settlement roughly 40 times over 11 months for soil and building settlement. And then we set awful lot of control for the parking lot construction, and then did a layout on 44th Avenue. So I'm gonna kind of get into our control networks. So in the middle of the image, you'll see that's kind of the building pad, and then the outside is the construction limits. So we set our primary control network basically to box out the site, which is outside any 3D modeled area, and that's kind of ideal for machine control. We established this control before the design phase started, and then we carried this control through the life of the project. This control was used for mass grading, for the placement of a lot of the parking lot, concrete, curb and gutter. And it also helped us establish our secondary control network, which is, you'll see, is a lot larger, and it's in closer proximity to all the curbs, because they use stringless paving for the curb and gutter and use some robotic paving methods for the flat work on site. So they essentially started in the east side of the site and then continued around the building counterclockwise. So we ended up setting this control in phases. This allowed us to set control. The stringless curb machine could go through and use it. And then we would establish control ahead of them so they could continue on laying curb. But then the flat robotic work had to use the same control, so we could then verify our previous control while setting new control to allow construction to keep going. We weren't able to set control too far ahead because there was still a lot of construction efforts going on in other parts. So that's kind of why we had to set it in phases. So I'll get into some of the traditional methods versus the stringless curb machine method. So a lot of us are used to seeing, a survey hub lath with vertical and horizontal information. They establish a string line so the curb machine can lay curb. And on the right side, you'll see kind of a 3D model, which was used to lay the curb and gutter in this case, but it's got to be paired with a pretty robust control network. So we get rid of the string lines, get rid of the hubs, and we rely on a 3D model and a solid control network. I will mention, we do set intermittent hubs and laths just so they can check the 3D model as they're laying it. It's not strictly just relying on the 3D model. So every 400 feet or so, high points, low points, we can put a hub and a lath in the ground. So as they're laying that curb and gutter, they can kind of check our lath and make sure that that 3D model is getting placed correctly on the ground. So here's kind of how the stringless curb machine works. You have a base station that they set up. They calibrate to our primary control network. This allows the machine to be steered horizontally, and then they supplement the GPS with a laser system to get tighter vertical tolerances. And then the curb would essentially be a geo-reference 3D model that they're designing the curb off or laying the curb off of. Here's a couple pictures from the site. On the right, you'll see the actual stringless curb machine that they used. And on the left, you'll see a big conveyor belt that's actually feeding the robotic flat work paving machine. So they essentially they've gone through, did all the curb, and they're setting those robotic total stations up on our secondary control network to lay all the flat work on the paving. So we didn't really essentially have to set blue tops. We didn't have to really do a lot of work when checking grades. They did a lot of fine grading off of our secondary control. So they would set robotic total stations up to fine grade all the parking lots. And then they would come through and use that same control to lay all the concrete. So with that, I think I'll turn it back to Andi.
Nothing? All right, got it. All right, now we're gonna go into the Q&A portion. So if you do have a question, just raise your hand and we'll run a mic out to you so you can ask the panel. But to start out, we are going to start with a poll. So for all of you out there, how long do your planning studies typically take on the projects that you work on? So go to pollev.com on your phone, or you can text it. You can see the information is up at the top of the slide. And we'll give you a few minutes to enter in some of your responses. So there's some answers coming in ranging from minutes to years. So a broad range of planning studies. Millennia, I like that one. So Sara, why don't you start by telling us how long the planning took for this project?
It did not take a millennia, I'll tell you that, and it did not take, let's say, one day. This planning traffic study took approximately 4 to 6 weeks, which is very typical when you're doing a planning study. Again, just to reiterate the size of Amazon and the different factors of trucks and different times to look at. It was lost my train of thought. It was definitely doable and took that average amount of time, but had good collaboration, like I said, too, which made it go smoothly. So.
That doesn't like me. I'll pause. Does anyone have any questions before we move on to the next poll? Feel free to raise your hand or be brave and blurt some questions out. All right, so the next poll is on the projects that you all have worked on. How many of you have encountered lime treated base? And I see some responses have already come in. Looks like many of you, almost half, have never used it before. And Ezra, I know you touched on it earlier, but do you want to talk a little bit more about it?
Yes. Lime treatment is commonly used in other parts of the country, more down in Texas. I know they use it an awful lot. As well as in Colorado. Some of the biggest benefits for it are reducing the swelling potential of swelling soils, which Fargo has in fat clays. But the other benefit for it is it really takes some of the moisture that's in the clay and sucks it out. So that, you know, and it's not lime that we can get from the Moorhead beet plants. Unfortunately, you are bringing it in. It's engineered lime. It's specific. It can't be a byproduct. Ultimately, there's a chemical reaction that occurs with the lime that pulls the water out of that moisture. So our moisture contents of our clay in the upper portion are in the neighborhood of 35 to 50, 35 to 40 most commonly. Optimum moisture contents for those of you placing dirt are in the neighborhood of 28 to 30. So we've got to bring that moisture content down anywhere from 8 percentage points to 10. The lime mix that they used was roughly a 4%, 5% lime. They blended it in the upper 6 to 12 inches. Ultimately, it brought that moisture content down overnight, creating an opportunity for us to move forward a whole lot faster than trying to farm that material out in order to dry it back so you can compact on it.
All right. You're up again. So how many of you all have encountered stone columns on your projects? Answers coming in. It looks like, again, about half of you have not used it. So we'll let the dirt man talk again.
The stone columns. So stone columns are a technique used to, you know, I was talking about some of the soft crust area, and we got those really settlement prone soils, and then we got hard material glacial till at the bottom. You know, where that gap is about 20 feet or so, 20 to 30 feet. You know, somebody can take a load from a building, MSE wall, highway bridge embankment, bridge abutment, transition it down to harder materials using what we call intermediate foundations, which ultimately act to kind of transfer that load a little bit differently than piling, because on piling, the load goes only through the column. In this case, the load goes through the stone column as well as the soil right next to it and spreads it out. You can use typical slab on grade construction above it. As far as how they work, ultimately we're drilling a hole in the ground. Roughly in this case, they were 28 to 26, 23 feet, 23 to 28 feet deep on this site. Ultimately, they drilled a hole in the ground about 18 inches in diameter, put rock down it every couple, about 6-inch lifts, and then ram it down and vibrate into place. So you're taking that rock and you're pushing it out into the soil next to it, creating kind of a dense, jagged column. That then helps to densify the soil in between the stone columns as well. And then that load ultimately gets transmitted through that, reducing the amount of settlement that you have to manage as part of it.
Thanks, Ezra. I forgot to mention, whoever asks the first question gets an Amazon package delivered to their table. So, just kidding.
I got a question.
All right. What about stringless paving? So how many of you out there have ever used or encountered stringless paving on your projects? Results are coming in. So Chris, why don't you talk a little bit more? Looks like we've got people who have used it on a few.
Yeah, it looks like we got about half of you guys that have used it on a few projects. I'd just like to reiterate that it's really dependent on how good your 3D model is and how good your control network is. Without one or the other, it's not going to work as good as being able to see an error in a string line like you typically would be able to see. And it also has its limitations since the curb machine is being steered by GPS. As we saw in this project, we got on the west side of the building, you have a 50-foot concrete wall, you start losing your sky plot and your GPS. The horizontal tolerances kind of went down, and it was not a good place to use the GPS steering on this particular machine. So
Chris, what's really the benefit of stringless paving?
some of the benefits, I would say, you don't have to wait for string line to be placed. So if you show up on site and you could essentially drop your paving machine off and you could have concrete there and grading completed. You wouldn't be waiting for somebody to set string line, which can potentially speed up the process.
Okay, thanks. And if we don't have questions, Sarah, I might ask you one. I know I get an Amazon package delivered to my house like every day. So there's probably a lot of trucking operations on site. How did that impact the traffic study?
Question, Andy. Yes, you're right. There, trucks is a part of every traffic study that we look at. The level of intensity or degree varies. So like Andy said, Amazon facility also needed trucks to be looked at, whether it's for queuing issues at one of our intersections, for turning movements and designs to make sure the trucks can get to a certain entrance or parking lot. And then also safety related. And so there's just a lot of components that the trucks took into account.
A question. We'll start here. Okay, we'll start with you.
I know you joked about the speed bumps, but after the winter that we had, has there been any follow-up on whether they had problems with it?
Thank you. Yeah, that's a great question. And just to be clear, we, with the entire parking lot being concrete paving, Amazon did not allow the kind of bolt-on removable speed bumps. So we kind of designed our own unique concrete speed bump throughout. So it was designed with the snowplows in mind. But no, it's a great question. I haven't heard anything. Certainly when we do our warranty walkthrough next year, it definitely will probably be a topic of discussion. So I'm curious to see how they panned out for sure.
I think we have one here.
Thanks. I had, I guess, a couple questions. One, was Ryan then the general contractor for the project?
Yeah, Ryan is the general contractor on the project and actually the building owner as well. Amazon leases the building through them following construction.
Okay. And then how many employees do you know if it created jobs for?
Yeah, the peak season, they estimate about 1,000 employees operate in that facility. It drops off obviously as demand goes down, but ramps up again that August through December timeframe every year.
Okay. And then last one, with adding, I guess was like the lime ash, cement mixing was, and the concrete paving, was that all in the budget initially, or did Amazon say, we want this done as soon as possible, you know, we'll basically pay anything?
I could take a stab at that, Ezra, maybe you want to add to it too, but like we mentioned, you know, the driving factor in the budget was really timeline. So they came in, we started this thing in June, July of 2020. We knew we had to hit a delivery date of August 2021 in order for them to make the financials work out on the project. So it was an iterative process back and forth among consultants, you know, contractors, things like that, to really identify what the budget was going to be, how they were going to proceed, and really what the, you know, what factors were going to drive milestones.
I think that the unique thing about this project is the owner, the developer, and the contractor, because Ryan Companies was both, and the owner were all involved from the very beginning. So as we're setting target milestone dates, as we're determining what kind of construction steps to take, the impacts of those are being handled in real time. So, you know, we're ultimately having meetings every week, in some cases twice a week throughout the design process to talk about, okay, where's architectural, where's underground, where is structural, where is soils, where are we at with all these? And it was, I think that was the most unique thing about the project to me, the delivery, because timeline was so critical. The amount of coordination that went into it was a lot higher than normal, which you would expect, but it led to a quality project where I felt like all the partners were heard and came away feeling like it was a successful project.
Tom?
160 million.
Got a question in the back?
Thank you. I was just trying to find out from a non-engineering perspective, how you guys managed to get work done in the cold and manage all the concrete that you had to pour in the cold, in the extreme cold.
We love constructing in North Dakota in the winter, right?
Well, I'll take that just because it was a big topic of conversation on the materials testing side of things. We were, I would say, fortunate in that last year in Fargo was not like this year in Fargo. There was not near as much snow. There was only a few of the 20 to 30 below days, not for weeks on end for a little while there. But they paved right up until the end using as much as they could from a temperature control standpoint, adding hot water at the plant, quick cures, high earlies, low fly ash. Ultimately, the goal being to gain strength early as we can and keep the ground thawed as well. Once they got into the building part, they had thawzols on a lot of that stuff throughout the course of the winter in order to keep that project moving. But really, it didn't matter if the ground froze, because in the wintertime, most of what they were doing was tilt-up panels for the precast and the roofing. So it wasn't until the spring when we're placing the slab on grade down that the frost being out was most critical. So unfortunately, the conditions are what they are, and the guys and gals on site did an awful lot of work in the cold. They did have temporary warming huts that they were used frequently, were kept heated. They were put up in multiple locations so people could get warm. And then really it's just taking breaks and wearing the appropriate equipment and doing everything you can. Obviously there were days it was too cold to get work done and it just wasn't done.
Thanks, Ezra. Other questions? Well, you see our last poll on the screen, which ties to technology. So we've got some answers. How are you all seeing the industry transform in terms of technology? And maybe I'll pass this to Tom. How did technology play into Project Force?
Sure. I can't comment on the salespeople, unfortunately, but I'll touch on the digital plans and maybe the automation. So kind of mentioned it during the design process. We didn't issue plans for construction until October. And I would say about 90% of the utilities and earthwork was done at that point. So it was a constant process. We were coordinating with the contractor and giving them those digital files so that they could build off of. So definitely took advantage of the technology there.
Also had to do, almost a lot of forced technology because obviously COVID was still going on. So meetings were happening over the course of screen sharing on Teams. A lot of more frequent meetings, sharing. I think you guys were sharing digital files too from survey multiple times too. So there was, again, a lot of coordination using all efforts.
No, you're good. Thank you. I think we have a question up front here.
What design software did you use for a 110-acre site? 50 feet, the volume to control the accuracy needed to build this?
The entire project was designed using Civil 3D.
Other questions? Oh, sorry, right here.
Column, same at the vibro flotation. Stone columns, is it the same as a vibro flotation?
Similar, if I understand what vibro stone columns, they're trade names, vibro stone columns. There's there's different companies that do them. They're also called geopiers. They're a bunch of different trademark names, but yeah, they're a design build system that are kind of trademarked by the different companies that do them, but they're all very similar.
I think we got a question in the back.
I think I heard it.
The nominal size of
The nominal size of rock for the stone columns. It was clear stone, 1.5 inch rock. Ultimately, they're pushing down, densifying and pushing out.
Other questions? Maybe I'll ask one for the whole panel. What do you think made this project successful? And you all can pick who wants to answer first.
I can start with that one. I think the ultimate success was really just the collaboration, coordination amongst all the consultants, the owner, the client representatives, and then all the local authorities, working with the city, the county, the DOT, the number of meetings we held, the openness, willingness to work share, just the overall the coordination among this project was something I've never seen before. And I think that's what really drove it to be a successful project in the timeline we had to work.
Yeah, I would definitely agree with Mike. Maybe just one thing to add on that collaboration is no problem was ever just, oh, that's Ezra's problem, I'll let him deal with it, or everything we dealt with as a team, as a group, to make sure we were all in alignment and to get the best possible solution as soon as possible to keep the project moving. So.
As a consensus on our side is collaboration as well.
I got one more. I just think, and the other one is that, what stunned me multiple times going on to that site is the amount of equipment that was running around in a small area, managed efficiently, directly. So it's the experience of contractors, that can experience contractors that can come in and get the work done and bring a team approach, even though they may not, Ryan Companies isn't from Fargo. They don't have an office. They don't work in those soils, but they partnered very well with the local subcontractors, the city permitting departments, the groups, all the approval processes that had to go through there. Again, it takes not the design team, but also the permitting approvers, the owner, and the contractors in order to really make this happen.
Yeah, I'll piggyback on all that. The collaboration was huge. On site, we had daily site meetings in the morning with all contractors on site that were currently doing work, which was a huge benefit, because if there was a change throughout the night, or if some contractors worked later than others and there was a change that got addressed right away in the morning on that morning meeting, questions could be asked, answered, which was a huge part of the speed of progress of the project.
And I think we have a few minutes left if we have any last questions.
Large project, all that, how did Ryan Companies come on the project a little bit?
Did you guys get that with all of the equipment? How did Ryan Companies ensure it was safe to come on site? Is that?
Yeah.
Tom?
Specifically related to COVID protocols, Ryan Companies had essentially a guard shack when you first came on. You got your temperature taken, I believe, every day. And there's some other checks involved in that as well. So as far as general safety, again, those meetings that Chris mentioned, every trade that was representative for the day's work had to have a superintendent or a project manager at those meetings. I think that really helped facilitate that safety around site.
Any other questions? All right, well, thank you all for joining us today. We do have a booth outside if you want to learn more about Project Force. The panelists today will be out there, and you can stop by and ask us any questions. Thank you.